Hello everyone, I'm Sanat Kumar from the Department of Chemistry, IIT Kanpur, and today I'll be taking 12th lecture on continuity and differentiability. So let's start. So today I'll be discussing derivative of the complicated functions and how we solve it. So we call it derivative using log function. Let's say derivatives using logarithms. So sorry, let's say we have a function. Let's say y is equal to, we have a complicated function. Let's say y is equal to square root of x times x plus 4 to the power 3 by 2 by 4x to the power 4 by 3. Suppose we have this function. If we have to differentiate it using the formula that we have studied earlier, u by v is equal to u dash v minus v dash u by v square. If we use this formula, it will get way too complicated. And if we use this thing, using these two identities, if we means two for derivative formulas, if we do this derivative, it will get way too complicated and we won't be able to handle the equations. So what we do in this case, we take log on both the sides and then we do the logarithm. So means do the derivative, sorry. So we don't use this thing. Instead, what we do, we take log. So taking log on both the sides. Sorry. Let's say we have, this will become log y will be equal to log of this thing, this whole thing. So it will be this x to the power 4, x plus 4 to the power 3 by 2 by 4x minus 3 to the power 4 by 3. This thing we have, and we already know the property of log. Thus, everything that is in multiplication can be written in forms of addition. So this will become log of this plus log of x plus 4 to the power 3 by 2, and whatever is denominator will be in negative. So this will become, sorry, I skipped one step. So this will be log of 4x minus 3 to the power 4 by 3. 4 by 3, yeah. So this is what we have, because we know log of, since log of m times n is equal to log of m plus log of n. We know this identity. And log of m by n, and m by n will be equal to m times n minus 1. So again it will be, okay, let me write it down. So log of m by n will be equal to log of m minus log of n, that we have already learned, and log of m to the power n will be equal to n times log of m. So next step, we will be using this thing. So what we have here is log y. Here I have written just the identity. So again, we are continuing our derivative thing that we had in the question. So log y will be equal to log of square root of x can be written as x to the power 1 by 2. And we already know log of m to the power n will be equal to n times log of m. So this can be written as half of log of, sorry, not m, it is x. Again, we have plus log of x plus 4 to the power 3 by 2. So this will be 3 by 2 times log of x plus 4. Again, the next term will be minus 4 by 3. Then n is equal to 4 by 3 here. So this will be minus 4 by 3 log of log of 4x minus 3. So this is what we have. Now what we will do, we'll take derivative with respect to x on both the sides. So differentiating with respect to x on both the sides. What we'll do, we'll find the derivative on both the sides with respect to x. So we have learned, okay, let's do it in one more step. D by dx of log y will be equal to d by dx of half of log x plus 3 by 2 times, I mean, yeah, it can be written like this, but d by dx of 3 by 2 log of x plus 4 minus d by dx of 4 by 3 times log of 4x minus 3. So this is what we have. Now we already know we have to apply chain rule here because the function is in form, means log y is a function in y. So what we'll do derivative with respect to y, and then we will find right dy by dx. So using chain rule, it will be d by dy of log y times dy by dx will be equal to, it is not clear here, so let's move to the next page. This will be equal to d by dx of, sorry, dy of log y times dy by dx will be equal to d by dx. We can take out half outside because it's a constant. D by dx of log of x plus 3 by 2 is a constant, so we can take it out of the derivative, times d by dx of log of x plus 4. And the last term will be minus 4 by 3 times log of d by dx of log of 4x minus 3. Now we already know log of derivative of log of something will be equal to inverse of that inverse of that variable. So this will be 1 by y times dy by dx will be equal to half of, this will become 1 by x, and the next term will be 1 by x plus 4, and this will be log of this thing will become 1 by 4x minus 3. And again here, since x was had no coefficient, I mean, what we did here, let's write it down. Let's say we have it, let's say u. So what we do, see what we did here is du by dx is equal to log of x plus 4, which is a function of x plus 4, not x, will be equal to d by d of x plus 4. I mean, it is not the conventional way to write it. So let's say this thing is equal to another thing m, d by dm of log of m times dm by dx, and dm is equal to x plus 4, that is equal to derivative of x with respect to x plus derivative of 4 with respect to x. This will become 0, this will become 1, and if we multiply this thing here, this thing becomes 1. So whatever we did, 1 by m, so this gives this thing the same value over here. But in this case we have, this will be, let's say this thing is, this thing d by dx of log of 4x minus 3 will be equal to 1 by, sorry, d by dx of log of, let's say, n times, which can be written as derivative of log n respect to n times derivative of n with respect to x, where n is this thing. So what we'll do, this thing, if we do the derivative, this will be 1 by n times, and dn by dx will be equal to d by dx of 4x minus d by dx of 3. That will be equal to 4 minus, this will be 0. So we have here 4. So this thing will become 4. So what we are supposed to do, we have to multiply this term with 4. So this is now our log. Most of the time we forget this coefficient. If x has a coefficient or not, we forget this factor, and then after we do a mistake. So we'll need to avoid it. So here it was 3, here it was 1. Yeah. So let's proceed. 1 by y is equal by dy by dx will be equal to 1 by 2x plus 3 by 2 x plus 4 minus 16 by 3 4x minus 3. Now this is the thing that we have. So let's write it down. Dy by dx will be equal to this whole thing, 1 by 2x plus 3 by 2x plus 4 minus 16 by 3 4x minus 3 multiplied by y, and we can write down y that we had in the question, this thing. So let's write it down. Will be equal to this terms. I'm not increasing the number of steps, so I'm simply writing the value of y that was there in the question. So it was root under 4, sorry, this was root under x plus 4 to the power 3 by 2 by 4x minus 3 to the power 4 by 3. So this is the thing that we had. Now let's move to the next question. Let's say we have a function, we have y is equal to x to the power 10x plus x square plus 1 by x. Now it is in the form of u plus p. So either we can use the log or we can avoid the log. It's up to us. So what we can do, we will take individually both the functions, because if there is addition in between, there is no use of adding log in the whole function, because it will only complicate the things. So what we are going to do, we'll take this thing as u, or let's write it in a proper way. Let u is equal to x to the power 10x, because there is no identity which says x plus y. I mean, that deals with x plus y in the logs. So there is no use of putting log on the whole y thing. So what we'll do, we'll take the individual functions u and v is equal to root over x square plus 1 by x. Now what we will do, we will solve the derivatives individually, because this will be dy by dx will be equal to derivative of, we have taken it u, oh sorry, let's not write it here, dy by dx will be equal to dy dx of u plus dv by dx. This is what we have to solve for. Now this thing, this can be solved in chain, using chain rule, but this one is a complicated one. So let's solve for du by dx first will be equal to d by dx of x tan x will be equal to nx to the power n minus 1, or no, we can't do it because the function is not a constant. So what we'll do, before that we will take a log function. U is equal to, because this identity can be applied only when n is a constant. Where n is a constant, but here this is not the case. So what we have to do, we have to do the log, and then after we have to find the value. So log u is equal to tan x log of x. So dx by d by dx of log u will be equal to d by dx of log x times, so sorry, plus d by dx of tan x times log x. I mean, better to write it on this side to avoid confusion. This will be equal to, this implies 1 by u times du by dx will be equal to tan x by x plus log of x times sec square x. That is what we have learned. So this implies du by dx will be equal to, this thing is tan x by x plus log of x times sec square x times u, and u we have x to the power tan x. So this is our first part. Now we have to solve for the second one. So let's say log of v will be equal to, we have a square root. So first let's write down the whole function, the square root of x square plus 1 by x. So this is the function. Now what we'll do, first we know this identity. I had written it before. Yeah, this one. If there is m to the power n, so n will come out. So here half is there, so it can be taken out. So log of x square plus 1 by x. This is what we are left with. Now this will become, that will be equal to half of log of this is m by n, so this can be written as log of x square plus 1 minus log of x. Now we have to find d by dx of log of v. So this will be equal to sorry, d by dx of log of x square plus 1 minus log of x. So this is the thing that we have to solve for, and sorry, this will be equal to derivative with respect to log v times dv by dx will be equal to, here we have to do the derivative. First we will take out half, and now d by dx of log of x square plus 1 minus d by dx of log of x. Now since we know log of, derivative of log of v will be equal to 1 by v times dv by du, or d by dx will be equal to half times this derivative will be equal to derivative of this log function multiplied by derivative of the polynomial function that is inside the log. So this will be equal to, either we can do it step by step or we can do it in one go. This will be equal to x square plus 1 times derivative of this function will be 2x. What we are doing, we are derivative doing, taking this thing, let's say take it m, find the derivative, it will be equal to 1 by m times derivative of m, the derivative of m d by dx of m x square plus 1 will be equal to 2x. So what we are doing, we are avoiding this step and simply writing 2x. Again, this will become 1 by x. So this is the thing that we are left with. So dv by dx will be equal to half times v times 2x by x square plus 1 minus 1 by x. And again, we have to write down the value of v. So we'll have the value. So this gives dv by dx is equal to half times x square plus 1 by x times 2x by x square, 2x by x square plus 1 minus 1 by x. I think it's minus, yeah. So this is the thing. Now what we are supposed to do, we have to add both the parts. So therefore dy by dx will be equal to this thing 1 plus 2. It is too complicated to write it down, but let's do 10x by x plus log x times sec square x times x tan x plus half x square plus 1 by x. This can be written as x square plus 1. This will become 2x square minus x square plus minus 1. That will reduce to x square minus 1. So this is our final answer. So let's do another example. Let's say we have x to the power y plus y to the power x is equal to a to the power b. What we have to do, we have to find dy by dx. So what we are supposed to do, first we will take this as v u, this thing as b, and we will find the derivative. So du, first let's say log. Let's take log. Log of u will be equal to y times log of x, and log of v will be equal to x times log of y. Now what we are supposed to do, we have to do the derivative. So we already know 1 by u times du by dx is equal to, basically what I am doing, d by dx of log u will be equal to y times log x derivative. So this will be equal to du by dx times 1 by u will be equal to dy by dx times log x plus y times 1 by x. So this is what we are left with, and we will write du by dx will be equal to dy by dx. We are getting dy by dx, but first we have to replace the u part so that we can add up it to into the final, I mean, the initial thing that we had. So it will be this thing plus y by x times, here u is equal to x to the power y. This is the first part, and this is not the du by dx. So dv by dx will be equal to log v is equal to t by dx of log y x times log y. This is what we had here, this thing. So this thing will be 1 by v times dv by dx will be equal to derivative with respect to keeping x constant, derivative of log y plus derivative of x keeping the log y constant. So this is the thing that will be equal to, this is plus dy by dx will be equal to, this derivative will be 1 by y times dy by dx. This can be written as x because we had x in multiplication, plus log y, this is what we had left with, times v, and for v we had y to the power x. So we'll add up these values, this thing 2 and 1 will add to the initial thing that we had, this, yeah. So this will become what we had initially, x to the power y plus y to the power x is equal to a to the power b. If we take derivative with respect to x on both the sides, plus this will become e to the power b will be equal to 0 because this is a constant, and x to the power y for the u part we got this thing 1 dy by dx times log of x plus y by x. This is the whole thing multiplied by x to the power y. Now here what we'll have, y to the power x times x by y dy by dx plus log y. Now what we have to do is equal to 0. So we have to rearrange it so that we can get dy by dx on one side and the rest of the things on the other side. So what we will do, dy by dx log x, let's simplify it. So this will become this plus y by x to the power x to the power y will be plus x y to the power x by y. This can be written as x y to the power x minus 1, and here it can be written as y x to the power y minus 1, and this will be dy by dx plus x to the power y times log y will be equal to 0. Now we'll take dy by dx common in the terms, x to the power y times log of x, and here it is plus x times y to the power x minus y minus x minus 1 will be equal to y x to the power minus 1 minus x to the power x log of y. So dy by dx will be equal to minus y to the power x y times x to the power y minus 1 plus this thing log y by x to the power y times log x plus x y to the power x minus 1. Now the answer is written such that the y terms has been taken out in common. No, no, this is the answer. Yeah, that is the answer. So now what we'll do, we'll move to the next topic, that is derivative of infinite series. That is an interesting one. So let's say derivatives of an infinite series. So here what we'll do a simple substitution in this series, and we'll get an answer. Suppose, let's say let's do it with an example. Let's say we have y is equal to x to the power x to the power x to the power so and so forth up to infinity. Sorry. So what we'll do here, we have to find dy by dx. We have to find dy by dx. So let's do one thing. What again? Let's put log. Okay, yeah. Let's start with putting log, and I'll explain why we did that. Log of y will be equal to log of x to the power x to the power x to the power so on and so forth up to infinity will be equal to, can be written as log of, sorry, x to the power x to the power x to the power so on and so forth times log of x. This can be written because we have done, we have taken out the exponent part outside, and now we are left with log of x. So what we will do, and we already know this thing, infinity, we something which approaches to infinity, if it means that is something that we can't attain. So that should be infinity minus 1, but there is nothing like infinity minus 1. I mean, that is an infinite series. Suppose you think of the biggest number that you can imagine, and now subtract the 1, means it will be 9999999, too many nines, and minus 1. Then if you do minus 1, but it won't be a finite number, no, it is an infinite. So what we can do, we can write it again as y. So this term will again become y times log of x, because if you reduce one term from an infinite series, it won't make any difference, it will again be an infinite series. So we have replaced the thing with y. Now here what we have is, so this whole equation becomes log of y is equal to y times log of x. So this is what we have. Now we have to find dy by dx. So what we'll do, d by dx of log of y will be equal to d by dx of y times log of x. This will be equal to log of, we will differentiate it with respect to y times dy by dx. So that will be 1 by y times dy by dx is equal to dy by dx times log of x plus y times derivative of log of x with respect to x, that will be equal to, this thing will become 1 by x. So this is what we have. Now what we'll do, we'll put dy by dx terms on one side. So it will be like, this implies dy by dx will be equal to, here we had 1 by y minus, if this terms comes on this side, it will be have a minus sign, minus log of x will be equal to y minus x. Yeah. Oh, y by x, sorry. So dy by dx will be equal to y by x times 1 by y minus log of x to the power minus 1. So what we can do, this can be written as yeah, this can be written as dy by dx, taking denominator y times log of x. So we'll write it here. This will become y by 1 minus y log of x. And this is the thing that we are left with. So this will become y square by x and 1 minus y times log x. Now let's do another example. Let's say we have y is equal to sine x to the power sine x to the power sine x, so and so forth. So what we'll do again, we'll take the log at first. So log y will be equal to sine x to the power sine x to the power sine x up to infinity times log of sine x, which is basically y times log of sine x. So what we'll do, we'll find dy by dx. So this side will be d by dx will be dy by dx times 1 by y will be equal to d by dx of y times log of sine x. So this will become dy by dx will be equal to derivative of y with respect to x. So this will be dy by dx, keeping the log of sine x constant, and plus y derivative of log of sine x, which will be equal to 1 by sine x times derivative of sine x will be equal to cos x times dy by dx plus y derivative of log of sine x times dy by dx plus y times 1 by sine x cos x, which will be equal to, this implies, what we'll do, we'll take we'll put dy by dx terms on one side. So dy by dx will be equal to 1 by y minus log of sine x will be equal to y times cot x. So yeah, now the next thing is we'll simplify this term, then after we'll put it on the other side. So this implies dy by dx will be equal to by y 1 minus y times log of sine x will be equal to y times cot x. Therefore dy by dx will be equal to y square times cot x by 1 minus y times log of sine x. So this is the answer. Now let's do the final part of this question of this chapter, which is let's move to the next page. Yeah, derivatives of one function with respect to another function. In this thing, we do similar thing that we do in chain rule, except that in this case, instead of multiplying, we divide the two derivatives. Let's see it. I mean, let's figure out with an example. Let's say we have uh, sine inverse x, and we have to differentiate it. Differentiate with respect to uh, tan inverse x. So let's say this is u, this is v. So it can be written as we have to find du by dv. That will be equal to du. Since u is a function of x, we have what we'll do, we'll find derivative with respect to x by dv. Oh, sorry. Let's do one thing. Du, we are dividing numerator as well as denominator with dvx. So this is equal. This should be equal. So what we are left with is derivative of u with respect to x by derivative of v with respect to x. That is u dash by v dash. So this is what we have to do. So first we'll do du. This is what we have to find, and this is what we are expected to do. So du by dx will be equal to a derivative of sine inverse x with respect to x, that will be equal to 1 by 1 minus x square root. This is derivative of sine inverse, and dv by dx, which is basically derivative of tan inverse x, will be equal to 1 by 1 plus x square, that we have already learned in our previous class. So du by dv, that is derivative of sine inverse x with respect to tan inverse x, will be equal to du by dx by dv by dx, that is equal to 1 by square root of 1 minus x square by 1 by 1 plus x square, that is equal to 1 plus x square by square root of 1 minus x square. So this is the derivative of sine inverse x with respect to tan inverse x. Let's do another example. And yeah, so let's say we have tan inverse 1 plus x square by 1 minus x square, and here we have 1 plus x square and plus 1 plus x square, and we have to differentiate it with respect to cos inverse of x square. So here it is our u, here it is our v, so we have to find du first. So du by dx will be equal to let's simplify the u first. U is equal to tan inverse of 1 plus x square minus 1 minus x square by 1 plus x square plus 1 minus x square. So if we look into this type of equation, what we can think of is a substitution. So let's say x is equal to, there should be a formula where we can substitute all these values and we can come up with, we already know, there should be something that we can substitute so that it can give a square. So if we remember the formula of cos of 2 theta minus 1 is equal to cos 2 theta minus 1 is equal to, or sorry, this is equal to cos square x, cos square theta minus sin square theta. Yeah. So if we subtract 1, so what will end up with? It will become 2 cos square x. Yeah. So we can do such substitution and let's see what happens. Yeah. So let x is equal to cos 2, let's say theta. Yeah. Then u will be equal to tan inverse of square root of 1 plus cos, sorry, x square. Yeah. X 2 theta minus 1 minus cos 2 theta by square root of 1 plus cos 2 theta minus square root of minus cos 2 theta. That will be equal to tan inverse of, this will become, we just did it earlier, so it will become 2 cos square theta. This will become square root of 2 sin square theta. This will again become 2 cos square theta. This will become, I think I've messed up the sign here. Yeah. 2 sin square theta. Now this will be tan inverse. We can cancel 2, take out 2 common and cancel in the numerator and denominator. So what we are left with is cos theta minus sin theta by cos theta plus sin theta. So that will be equal to, what we can do here, if we divide the both the terms, I mean the numerator and the denominator inside the bracket with cos theta, we will be left with tan theta because we have to take in cancel the inverse function. So what we can do, tan inverse can be written as, I mean this thing can be written as sin theta will be tan theta and this will be 1 plus tan theta. So again, what we can do, this will become, this can be removed with an identity. Now, yeah, a plus b by a minus, yeah. So this can be written as pi by 4 minus b by, I mean, yeah, theta. This is the identity that we have used. So will be equal to, we can take out the tan. This will be by 3 minus theta. So, and so this is the function that we are left with. So u is equal to this. Now du by dx will be equal to, we have to substitute this thing, theta is equal to cos inverse of x square by 2. So will be equal to pi by 4 minus 1 by 2 cos inverse of x square. And we have to find du by dv. Since v is here, cos inverse of x square, this is the thing that we have, v. So whatever the derivative is, du can be written as, this will be equal to 4 minus v. So it will become du by dv will be equal to pi by 4 v d by dx, this thing, by dv by dx, which will be equal to pi by 4. This will become 0. D by dx of pi by 4 will become 0. This will be 0 minus dv. Sorry, it will be half times dv, half times dv by dx. And again, this will be dv by dx. So what we are left with is minus 1 by 2. So this is our answer. So we'll end this session here. All we are left with the second order derivative, which definite derivative of a derivative. So what we do in this case is differentiate a function with respect to a particular function, and then we differentiate it, and we are left with parametric functions. So okay, we can do it in our next class. So that's all for this class.